Lesson 53 is about the power rule for exponents and conversions of volume. Now the power rule for exponents is written here. Please take a moment to pause the video and copy this into your notes. The power rule for exponents says a to the mth power all raised to the nth power is equal to a to the mth power times the nth power. So what we're doing really here is we're just multiplying these two together to find our answer. Let's go ahead and look at some examples. Here we have to simplify. The first one we have is a to the fifth squared. Now what a to the fifth squared means is a to the fifth times a to the fifth. And if we look at a to the fifth times a to the fifth, we can tell that's a to the 10th because there's 10 powers there, 5 and 5, that must be 10 when we add them. And we've got our answer, a to the 10th. Now we used a middle step there by expanding this out. The other way we could have done it using that power rule would have been 5 times 2. That's 10, and we would have had a to the 10th. Let's use that rule for our next problem. Here we're going to have x to some power. We have negative 4 to the negative second power. Well, we must have to multiply those together. Negative 4 times negative 2, that's going to be positive 8. So we've got x to the 8th power. And then in the next one we have m to the k power all raised to the second power. Well, if we multiply, we're just going to get m to the 2k power. This power rule is nice because it allows us to solve problems where we're raising a power to a power. Let's look at some more examples. Here we have to simplify. We want to write all answers with variables in the numerator. So what we're going to do is we're going to multiply all of our powers in this by 2 because everything is being raised to the second power. So we get 3 to the 0th raised to the second power. 0 times 2, we'll write it out. 0 times 2, that's just 0. Then we got y to the negative second power times 2 because it's being raised to the second power as well. Then we've got z to the 5 times 2. Oh, not 5 times 2, I just wrote the answer there. We want to write the workout first. 5 times 2. And then we're going to divide all this by x to the third, and that's squared. So now we can simplify. 0 times 2, that's 0. So 3 to the 0th power is 1, because anything to the 0th power equals 1. Then we get y to the negative 4th power, and we get z to the 10th power when we multiply through. We're going to divide all this by x to the 3 times 2, that's 6. And it looks like we're done, but we're not. Remember to read the question carefully. It said write all answers with variables in the numerator. So, in order to do that, we've got to bring our x to the negative 6 to the opposite side of the fraction. So we're going to make the opposite power. We're going to get y to the negative 4th, z to the 10th, x to the negative 6th, and now we're all done. We can leave that 1 off because 1 times anything is just that anything. We've got our final answer. We simplified by multiplying our power times the power that it was raised to, and then simplifying as we go. Let's look at our next examples for today. Now we've converted linear units like straight lines like miles to feet. We've converted units of area like square feet to square inches. And now we're going to convert cubic units. So this one says use 6 unit multipliers to convert 800 cubic centimeters to cubic feet. So to go from centimeters to feet, we're going to have to go from centimeters to inches to feet. So let's get started. We've got 800 cubic centimeters. So that's centimeters times centimeters times centimeters all over 1. We've got to multiply this by 6 unit multipliers. So 1, 2, 3, 4, 5, and 6. We're getting smaller as we go, but we can still see off the side. So in order to cancel out centimeters, we're going to need a centimeter, centimeter, and centimeter in the denominator. And we're going from centimeters to inches, so we need inches in the numerator. Now once we filled that in, we know we can cancel out centimeters, centimeters, and centimeters, and we can fill in our values. There's 2.54 centimeters in an inch, 2.54 centimeters in 1 inch, and 2.54 centimeters in 1 inch. We're halfway done. Now we have to go from inches to feet. So we need inches in the denominator now, so the inches cancel out. And we need feet in the numerator. We know that there's 12 inches in 1 foot, 12 inches in 1 foot, and 12 inches in 1 foot. If we look at it, all of our inches, all 3 of them on top, cancel with all 3 on bottom. So we're left with feet times feet times feet. Perfect. That's cubic feet. Feet to the 3rd power. And our answer is going to be, well, 800 times, well, these are all 1, so our numerator is 800. And our denominator is going to be 2.54 times itself 3 times. So let's write 2.54 to the 3rd power. And then we've got 12 times itself 3 times. And we're all done. These unit multiplier problems are really nice actually because you don't have to do the multiplication and division in order to report your final answer. Even if you love doing multiplication and division, like I do, you can still report your answer like this because it means exactly the same thing as if you were to multiply 2.54 times 2.54 times 2.54, then multiply that by 12 times 12 times 12, take that whole product, and then divide 800 by it. It would take a while to go through that. So instead, we use our time wisely. We report our answer like this. Make sure you've got the right label, and you can move on to the next question. Lesson practice will be on page 216. Make sure you've got your notes complete, and I'll see you during our next class.